Okay, we're back, and before I forget to mention this, acceleration we said was change in velocity over change in time. So I just wanted to restate that we're talking about rate of change of velocity. Whenever you have, let's say, acceleration, we know is the change in velocity over the change in time. So whenever you have this change in time, it implies a rate. So it's a rate of change of velocity is going to give you your average acceleration. And again, units are going to typically be in meters per second squared. All right, let's look at a velocity versus time plot. And when you have velocity versus time, the things you're going to be able to find are acceleration. So acceleration and sorry about that. Let's see here. We're going to look at this, and we have a straight line plot here. So when we might expect that we're going to be able to find acceleration from slopes. Okay, so let's take a look at this. What is the slope in this interval? The slope is positive, so our acceleration is positive. And we can get the acceleration by looking at the slope. Here we have a horizontal line, so the slope is 0, therefore the acceleration is 0. Now if this was not velocity but position, we'd be talking not about acceleration, but we'd be talking about velocity. So remember, position versus time plots, slopes are going to give you velocity. Velocity versus time plots, like we're doing here, slopes are going to give you accelerations. Now let's look over here. You see this slope is heading downward, so the slope acceleration is negative. It's less than 0. So here the slope is negative. So your acceleration is negative in this interval over here. I just wanted to point that out because we needed to know that. All right, that's about it with acceleration. Now, from learning what we've learned about velocity as the change in the position versus change in time, and then acceleration as the change in velocity over the change in time, we come up with the equations of motion. And the equations of motion are V final is equal to V initial plus acceleration times time, where this is the final velocity is equal to the initial velocity plus acceleration times time. In a like fashion, we could say that the final velocity squared is the initial velocity squared plus 2 times the acceleration times the change in position. Now, if we're talking about horizontal motion, we're talking about x position. If we're talking about vertical motion, we're talking about a y, delta y. So you'd replace this with delta y. And your velocities initial and final are going to be with respect to vertical. Then the last equation here is for displacement, which is the change in position, and that's equal to the initial velocity times time plus 1/2 at squared. Okay, if we continue along now, these equations hold if acceleration is constant. And there was one other one, and I'd always give these on a test. You could say the delta x is half v initial plus v final times time. This here is just the average velocity, and that holds only if you have constant acceleration. So these are our equations of motion. It's not necessary to memorize any of these. I'd always give these to you on a test. But anyway, they get derived from these two basic equations right here. Okay, so I think what we want to do next is come back, and with the next part what we're going to do is just discuss vertical motion a little bit and free-falling objects.